Hello students, this video is about Introduction to Chapter 8 Metals. Here you have the periodic table of elements starting from hydrogen, proton number 1, going down the group. Here this is the alkali group, hydrogen not included. Lithium, sodium, potassium, rubidium, cesium, and francium. That's group 1 alkali metals. And then beryllium, magnesium, calcium, strontium, barium, and radium. That's alkaline earth metals, group 2. And here you have group 13, boron, aluminum, gallium, indium, thallium, and then NH here. The column, that's a period, represents the number of shell of atoms. So period 1 hydrogen, meaning that hydrogen atom consists of one shell only. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. In a period 2, this is period, row is period. So this atom, lithium, beryllium until neon, have two shells of atoms. So the distance from the nucleus to the outermost shell electron are getting farther for the second period. For the third, getting more farther because there are three shells for sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So going down the group, the number of shells increases, then the distance getting farther. So it is easier for the outermost electron to be released, to remove from the atom, and then the atom form a positive 1 for alkali metal, group 1, for lithium, sodium, and so forth. For group 2, then there are 2 electrons to be released. That's the outermost shell electron. The number is 2. And then going down the group, the shell of atom getting farther. So it is a weaker attraction force between the positively charged nucleus to the outermost shell electron. Then it is easier, going down the group, easier for the atom to release the electron. So we can say that for metal, going down the group, when the distance, the radius of the atom getting bigger, then the metal will become more reactive. And then here, on the right hand side of the periodic table, we have non-metal. So we can say that going across a period, because metal, and then this is still metal transition, and then you have the metalloid here, aluminum, gallium in deep green color here. That's a metalloid, and then we have a non-metal. So we can say across a period, the reactivity of metal decreases and the reactivity of non-metals increases. Going down the group for a non-metal, here the number of shell of atoms getting bigger. Here the distance getting farther, the distance of nucleus to the outermost shell getting farther. Then the ability for the nucleus to attract electron towards its atom getting weaker. So the reactivity for a non-metal going down the group decreases. Here the general properties of metals, metalloid and non-metals. For metals, that almost all metals crystalline solids except mercury Hg, and then they readily share electrons. There are monoatomic, and then can conduct electricity and can conduct heat, high density, and form cations for metals such as Na, form Na plus ion, and metals form basic oxide, for example calcium oxide CaO, and during electrolysis on the cathode will form from the salt solution or from the molten salt of the metal, and then form a compound with ionic compound, ionic bond. For non-metal, um, having no metallic luster, and then so the appearance for non-metals usually dull, and then share electrons in forming the compounds to form a diatomic or polyatomic molecule. Metals cannot conduct electricity, and then cannot conduct heat, low density. For non-metal can form electronegative ion such as S2 minus, Cl minus, that sulfur ions or sulfide, and Cl minus chloride ion. When the non-metals join with metal in an ionic compound. And for non-metals, they form acidic oxide such as SO2 sulfur dioxide. That's acidic because with water will form acid. So the oxide we say as acidic. And then form stable compounds with hydrogen such as PH3 phosphine H2S hydrogen sulfide. We continue with metallic bonding. Metal have low ionization energy. That means that the energy needed to release the electrons for the atom is quite low, a small quantity of energy needed. It means that metals easily remove the valence electron from the atom. So after the electron release, then the atom become positively charged, and the outer shell electrons have become delocalized, not stay in one place or in one atom, but moving around all the atom here, so not bonded specifically into one atom. So the electron is mobile, or we can say delocalized, or not in one local place, but moving around. And then because this the electron is a lot, then we say as sea of electrons. The outer shell electrons have become delocalized over the whole metal structure. This means that they are no longer attached to a particular atom or pair of atoms, but can be thought as moving freely around the whole structure. That's why atom can conduct electricity because of the sea of electrons. Here you have a reactivity series, arrangement of metals in order of reactivity, starting from the most reactive potassium K until the least reactive gold. You can write from the top to the bottom or from the left to the right, starting from the most reactive. So the most reactive here is potassium, and then followed by sodium Na, followed by calcium Ca, and then magnesium, and then aluminum, and then carbon and zinc, iron, tin, lead, Pb, copper, Cu, silver, and gold here. When we have, for example, magnesium, then we react with zinc chloride, and there will be a reaction because magnesium is more reactive than Zn. So Mg will displace Zn from ZnCl2 to form MgCl2 plus Zn. So Zn is displaced from the salt. This displacement reaction represent the reactivity. When a metal can displace another metal from the salt, meaning that that metal is more reactive. The chemical properties of metal: 1. Most metal react with oxidizing acids to form salt and gas, except for platinum, Pt, and gold. For example, you have here iron, Fe, and then nitric acid concentrated will form iron trinitrate, and then water and gas nitrogen dioxide. 2. Less metals react with acids to produce salt and hydrogen gas, except for the metal less reactive than hydrogen. How do we know? The metals lays between hydrogen in the reactivity series to the left, that more reactive than hydrogen. So for iron can react with HCl because iron on the left hand side of hydrogen in the reactivity series. Or iron is upper hydrogen and in the reactivity series when we arrange from top to the bottom. Here, reaction of acids with metal. For example, the acid is hydrochloric acid, HCl, plus magnesium Mg will gives hydrogen gas H2 and magnesium chloride MgCl2. That's the salt. This is the salt and the hydrogen gas. We can test the presence, the existence of hydrogen gas. We can test using a glowing spin that will produce pop sound. For copper, because copper lay underneath the H in the reactivity series, then copper is less reactive than hydrogen, so copper cannot displace H from HCl. So between copper Cu and acid, non-oxidizing acid HCl, there is no reaction because copper cannot reduce H plus in HCl to be H2. For the reaction of metal with acid, here we use non-oxidizing acid, metal plus acid, to produce salt and H2. For example, you have sodium and HCl to produce NaCl plus H2. For zinc, Zn plus HCl to form ZnCl2 and H2. With sulfuric acid H2SO4, you have Zn plus H2SO4 to produce ZnSO4 and H2. For iron plus HCl to form FeCl2, iron 2 chloride and hydrogen gas H2. When the acid is H2SO4, then the salt is FeSO4, iron 2 sulfate plus H2 hydrogen gas. For copper, when we use the acid is dilute HCl, that's non-oxidizing acid, then there is no reaction. But when we use concentrated H2SO4, concentrated here. When we use concentrated H2SO4, which is an oxidizing agent, then there is a reaction between copper and concentrated sulfuric acid to form CuSO4. All metals react with oxygen except silver Ag, platinum Pt, and gold Au. In general, metals react with oxygen to form metal oxide. Oxide is a compound composed by an element with oxygen. For a metal, the type of oxide is basic oxide because the oxide, when react with water, will form a base or hydroxide. Group 1 metals except lithium produce compounds containing more oxygen. For sodium produces sodium peroxide Na2O2. Potassium, rubidium, and cesium Cs produce metal superoxides MO2. In general, metal oxides are ionic compounds because composed by a positively charged atom of metal and negatively charged ion O2 minus because oxygen is a non-metal. So for example, you have Na2O. This compound is ionic compound because composed by positively charged ion Na plus and negatively charged ion 2 minus O. Then because the charge of sodium is only 1, but the charge of oxygen is minus 2, then we need 2 sodium here. So the formula is Na2O. So Na2O is an oxide. The type of the oxide is a basic oxide because when react with water will form hydroxide NaOH. Here times 2. Reaction of metal with water happen to the very high reactivity of metal. The products are hydroxide and hydrogen. For example, for sodium, when react with water, will form NaOH and hydrogen gas H2. The equation is 2Na plus 2H2O to produce 2NaOH, that's the hydroxide, and H2 gas. For calcium, react readily with water. So for group 2, starting from calcium. For beryllium and magnesium, there is no reaction with water, except we heat the magnesium. For beryllium, there is no reaction at all. Going down the group, the reactivity of metal increases. So there is a reaction starting from calcium in group 2 to barium. Calcium, strontium, barium will react with water to produce CaOH2, SrOH2, and BaOH2 plus H2 gas. For magnesium, magnesium lay upper the calcium in the group of alkaline earth metal, group 2. So magnesium is less reactive than calcium. There is no reaction between magnesium and water. or the reaction occur very slowly, but there is a reaction of magnesium and steam to produce MgO, magnesium oxide solid, and hydrogen gas. For metal can mix with other metal to have better properties, and the mixture we name as alloy. Metal alloy is a solid mixture of two or more different metal elements. For example, steel, which composed by iron and other metals, and brass or bronze. Bronze is an alloy consisting primarily of copper, Cu, commonly with about 12 until 12 and half tin Sn, and often with the addition of other metals and sometimes non-metals or metalloids such as arsenic As, phosphorus P, and silicon Si. Here are some alloys. You have brass. The component of brass is copper, Cu, and zinc. Bronze, copper, and tin, Sn. Mild steel, iron, and carbon. Stainless steel, iron, chromium, Cr, and nickel, Ni. And solder, that's tin and lead, Sn and Pb.